Ever wondered how a cruise ship, longer than 3 football fields and taller than a city building, actually comes to life? How does a floating city with thousands of rooms, restaurants, pools, and even power plants get built from nothing but sheets of steel? Today, we're diving deep into one of the most ambitious engineering feats on Earth, the making of a modern cruise ship. From digital blueprints to the Maiden voyage, this is a story of scale, precision, and pure human ingenuity. So grab your life jacket and get ready. By the end of this video, you'll never look at the ocean the same way again. Before a single spark flies or a steel sheet is cut, the cruise ship already exists, inside a computer. Designing a vessel of this size isn't just about making it float. It's about making it function like a city at sea, with the elegance of a 5-star hotel and the complexity of a power grid. Naval architects spend years perfecting every curve of the hull. Using computational fluid dynamics, or CFD, they simulate how water and air flow around the ship. These simulations predict how efficiently it cuts through waves, how wind behaves across the decks, and how it responds in rough seas. Scale models are tested in water basins and wind tunnels. Every adjustment can save fuel and improve stability. Once the model performs flawlessly, the design is approved. The floating city is ready to be born. This is where imagination becomes reality. If design is the brain of shipbuilding, this is the muscle. At the shipyard, thousands of tons of steel arrive, giant plates that will form the ship's bones. Each one is cleaned, treated, and coated against corrosion. Salt water never forgives mistakes, and even a tiny rust spot can cause problems years later. High-precision plasma and laser cutters slice the steel with millimeter accuracy. Thicker plates build the outer hull for strength, while thinner ones shape the interior. Every piece must fit perfectly, like a massive 3D puzzle. Workers say this is where the ship truly takes form. Once cutting is done, the flat pieces are welded into large sections called blocks, the building units of the vessel. Modern shipbuilding uses modular construction, building huge pre-assembled sections instead of starting from the keel upward. Inside enormous shipyard halls, workers equip each block with pipes, insulation, wiring, and fixtures before it ever reaches the dock. This streamlined approach saves months of work and guarantees a perfect fit. Giant gantry cranes, taller than skyscrapers, lift the finished blocks into place. The first sections are positioned at the center, then others are stacked forward and aft like colossal Lego pieces. With every block added, the ship's form emerges. Walls rise, decks take shape, balconies extend outward. What began as flat steel now towers over the yard, transforming from an industrial project into a living, breathing vessel. If cruise ships are floating cities, welds are their glue. Every seam must be perfect. Skilled welders, often working in scorching heat and cramped spaces, fuse steel plates with pinpoint precision. Each joint is inspected multiple times by ultrasound, X-ray, and visual checks to ensure it meets exacting safety standards. A single flaw could mean disaster in rough seas. One welder describes the process best. We're not just connecting metal, we're connecting trust. Tens of thousands of welds hold the hull together, forming a structure strong enough to endure storms, waves, and decades of ocean travel. When the final seams are complete, the ship is ready for one of the most dramatic moments in shipbuilding, the float-out. After months of sparks and steel, the ship finally touches water for the first time. It's a milestone known as the float-out, a moment both technical and emotional. As tugboats gently guide the unfinished vessel out of the dry dock, engineers check the balance, ballast, and watertight integrity. It's no longer a collection of steel blocks, it's a real ship. For the first time, it floats on its own, resting in the water exactly as the simulations predicted. The sight never fails to draw applause from everyone in the yard. The ship is now alive, breathing through its ballast tanks, balanced by physics, ready for the next phase, bringing power to this floating city. Cruise ships don't plug into the grid. Once they leave the dock, they're entirely self-sufficient, floating islands powered by their own energy systems. At the heart of the ship are massive diesel-electric engines, some as large as a two-story house. Together, they generate tens of megawatts of electricity, enough to power a small city. This electricity is distributed through transformers and cables that run from the engine rooms to every corner of the ship. By the time it reaches a passenger's cabin, it's the same voltage you'd find in a home outlet. The system is built with redundancy in mind. If one generator fails, the others take over instantly. No blackouts, no shutdowns. Engineers describe it as an electric heartbeat that never stops. The power not only runs lights, elevators, and restaurants, it also drives the ship itself through cutting-edge propulsion systems. Modern cruise ships no longer rely on long shafts and rudders. Instead, they use azimuth pods, rotating motors mounted beneath the hull that can spin a full 360 degrees, giving the ship remarkable agility. The captain steers by rotating the pods, controlling the vessel with precision. It's like flying an aircraft underwater, one captain explains. Smaller bow thrusters at the front push the ship sideways for effortless docking in tight spaces. These innovations cut turbulence, noise, and vibration, making every voyage smoother and more efficient while saving fuel. But the ocean is unpredictable, and stability remains essential. That's where the ship's hidden wings come in. Beneath the waterline, two large fins extend from the hull, retractable stabilizers that act like airplane wings turned sideways. As waves roll the ship, the stabilizers counteract that motion, keeping passengers comfortable even in rough seas. Then there's the bulbous bow, the rounded nose protruding from beneath the waterline. It's not decorative, it's aerodynamic engineering. The bulb creates a secondary wave that cancels out the natural bow wave, reducing drag and boosting fuel efficiency. These small innovations save millions of dollars in fuel costs over the ship's lifetime and make the ride smoother for everyone aboard. A cruise ship isn't just a vessel, it's a self-contained ecosystem. It must create its own fresh water, purify its own air, and process every drop of waste without harming the environment. Using advanced desalination plants, seawater is turned into crystal-clear drinking water through distillation and reverse osmosis. The same systems supply water for showers, laundry, and even swimming pools. The air is managed by massive HVAC systems that filter, cool, and circulate air across hundreds of rooms. Engineers fine-tune the system so passengers never hear the hum of machinery or smell the kitchen from the spa. Wastewater is treated on board using advanced filtration systems that meet or exceed land-based environmental standards. Even the exhaust gases from the engines are scrubbed clean before leaving the ship's funnels. Everything is designed to keep the environment and the passengers safe. Beneath the polished decks and chandeliers lies an invisible network of technology. Miles of pipes, ducts, and cables snake behind walls and beneath floors, carrying power, water, and data throughout the ship. Fire safety systems divide the vessel into sealed compartments, preventing a single incident from spreading. Ballast tanks, managed by sensors and pumps, keep the ship balanced as it consumes fuel or takes on cargo. Every system is redundant, backed up by independent circuits, just like a data center. It's a city that can't afford to sleep, says one systems engineer. If one part fails, the others keep it alive. This hidden infrastructure ensures passengers experience nothing but peace, comfort, and quiet luxury. never realizing the complexity working beneath their feet. Once the engineering is complete, the ship's transformation turns from industrial to indulgent. The fitting out phase is where the vessel becomes a floating resort. Thousands of workers, electricians, carpenters, designers, and decorators board the ship to turn bare steel into ballrooms and suites. Every deck is filled with activity. Cabins are furnished, theaters take shape, pools are tiled, and restaurants are fitted with gleaming kitchens. Materials are chosen not just for beauty, but for function. Carpets resist salt air and foot traffic. Wood panels are treated for fire resistance. Every light fixture is vibration tested. Silence is key. Layers of acoustic insulation ensure guests never hear the engines or the waves outside. If you can hear the ship, one interior designer says, we've failed. After nearly a year of non-stop work, the ship's interior looks like a luxury hotel, ready for its first test at sea. Sea trials are the ship's final exam. Over several days, engineers push every system to its limit. Engines are run at maximum power, navigation systems are stress-tested, and emergency drills simulate real-world failures. Sensors record vibrations, noise levels, and fuel performance. If anything rattles or hums too loudly, it's fixed on the spot. Propulsion pods are spun in tight turns to test maneuverability. Stabilizers are extended to measure roll resistance, and water treatment systems are verified for environmental compliance. It's a moment of controlled chaos, pushing the ship to its breaking point to ensure it can survive anything the ocean throws at it. When the trials end successfully, the ship returns to port. There's a quiet celebration among the crew and builders. She's ready. Delivery day marks the true birth of the ship. Inspectors give their final approval, documents are signed, and the flag is raised high. Ownership officially transfers to the cruise line as the crew steps aboard, ready to bring the vessel to life. Final preparations unfold. Provisions are loaded, kitchens tested, staff trained, and safety drills rehearsed. Every corridor hums with anticipation. When the engines ignite and the ship glides from the dock on its maiden voyage, it carries more than passengers. It carries the pride and dreams of everyone who built it. But this isn't the end of shipbuilding. It's evolving. New cruise ships are embracing hybrid propulsion, hydrogen fuel cells, and AI-assisted navigation. Some even recycle heat to generate power or purify seawater. The goal is clear: a new generation of cleaner, smarter, zero-emission vessels that sail the world's oceans with power, grace, and responsibility. From flat sheets of steel to a glittering floating city, building a cruise ship is one of humanity's greatest engineering achievements. Every weld, wire, and window tells a story of innovation, precision, and teamwork. So the next time you step aboard a cruise ship, take a moment to appreciate the silent complexity beneath your feet, the engines, systems, and people who made it possible. If you enjoyed this deep dive into how these giants are made, hit that like button, subscribe for more incredible stories of modern engineering, and leave a comment telling us which part amazed you most. Thanks for watching, and we'll see you on the next voyage.